simpler, less-known worlds in our solar system that are just as interesting. 4 of them are known as the Galilean moons, Jupiter's 4 largest moons. Considering they are so close together, they are fascinating because they are so different. You have a volcano moon, a moon that has one of the best chances of containing life out of anywhere else that we know of, the biggest moon in the solar system, and an ancient, scarred moon whose surface can be traced back to the solar system's very beginning. I'm Alex McColgan, and you're watching Astronomy, and in this video we will go through these special worlds one by one, and do a deep dive into what makes each one so unique. By the end of this video, I'm sure you'll understand why they will be the subject of 2 missions this decade, from both NASA and ESA. We'll start with the innermost moon, Io. Io is one of the most curious objects in our solar system. The innermost of Jupiter's big moons, it has plenty of features that set it apart from anything else that we have ever seen, including volcanoes, aurora and a sulfur atmosphere. Let's get to know the context of Io a little better. Jupiter has 79 moons that we know of so far. There's a few that orbit close to the planet, in and around the planet's rings. Beyond that are 4 large moons, known as the Galilean moons, named after Galileo who discovered them in 1610. From innermost to outermost, these moons are Io, Europa, Callisto, and Ganymede. Beyond them are the irregular moons of Jupiter, all of which are much further out than the previous moons. Io orbits very closely to Jupiter, only 350,000 kilometers above Jupiter's cloud tops. This means from Io's surface, Jupiter would appear 39 times bigger in the sky than our moon. Io orbits Jupiter in only 42.5 hours compared to our moon's monthly orbit. At some points in its orbit, the tidal bulge on Io is thought to be up to 100 meters. This effect is similar to what we see on Earth, with the ocean's tides being caused by the moon. Although on Earth the effect is much more minimal, the tide's only usually shifting about 2 meters from high to low. Io is getting 300% more tidal force exerted on it in comparison to our moon on us because of its close proximity to the biggest planet in the solar system, Jupiter, and the other big moons in the system don't allow the moon's orbit to be less eccentric, meaning Io isn't going to get any rest by anytime soon. A day on Io is the same as its orbital rotation, which means that Io is tidally locked to Jupiter. Just like we can only see one face of our moon from Earth, only one face of Io can ever be seen from Jupiter. Io is a pretty big moon, although it is the second smallest out of the Galilean moons. Jupiter's moon, Europa, has long fascinated scientists and space enthusiasts. With its subsurface ocean and potential for life, Europa represents one of the most promising destinations for exploration and discovery in our solar system. In this video, we'll explore the journey to Europa, the challenges, and the potential opportunities that await us on this icy moon. Overview of Europa. Europa is the 6th largest moon in the solar system and is known for its smooth, icy surface. It's believed to have a subsurface ocean, which could potentially support life. Scientists believe that Europa's ocean may be more than twice the size of all the oceans on Earth combined. Challenges of a journey to Europa. The journey to Europa is no easy feat. It's a distance of over 600 million kilometers from Earth, which makes it one of the furthest destinations in our solar system. Additionally, Europa is exposed to high levels of radiation from Jupiter, which could damage spacecraft and endanger astronauts. There are also technical challenges, such as developing the technology for a successful landing on Europa's icy surface and exploring the subsurface ocean. Opportunities on Europa. Despite the challenges, the potential opportunities on Europa are enormous. The subsurface ocean could potentially support microbial life, which would have significant implications for our understanding of the origin of life in the universe. Europa also offers a unique laboratory for studying planetary processes, such as geology and the potential for habitability. Technology needed. To make a journey to Europa a reality, significant advancements in technology are necessary. This includes developing the spacecraft and propulsion technology to make the journey, as well as the landing and exploration technology needed to study Europa's surface and subsurface ocean. Advancements in